One of the features within Azure that we can use to help automate our tasks is Logic Apps. Logic Apps provide us with a way to orchestrate tasks in a way that makes it easy to get started, but also offers us the flexibility to really customize it in a way that make it work for our business. These workflows can include everything from simple automation tasks to complex business processes. There are a number of connectors out there to help integrate with your applications, whether it's a Microsoft application or one of the many third parties out there. Additionally, you can create custom connectors if needed. With this in mind, it can be extremely useful to help your existing applications work with new ones by handling how data is processed between them. So as you migrate your applications away from legacy technologies, this can make sure you can still expose the data to the newer technologies that may not have the ability to talk natively with one another. There are many similarities between Logic Apps and Azure Functions. They both use a trigger to initiate their process, and they're both serverless. Again, I say serverless with air quotes because essentially we are leveraging Azure to maintain the server instead of having to worry about it ourselves. The biggest difference is that with Logic Apps gives you the ability to create logic without writing any code. Additionally, there are several connectors available so you can easily integrate with other applications such as Salesforce, SAP, GitHub, as well as many others. Since we're familiar with the general concepts of how a Logic App works, since in many ways it's similar to Azure Functions, let's take a look at how we would set up our first one. The first thing we define is a trigger. Similar to a trigger in Azure Functions, this is what initiates the Logic App. These can be run on a timer or initiated by a connection. There are two main types. A polling trigger will use a recurring schedule to check another resource for activity. If there is a certain type of activity, it will then initiate the Logic App. A push trigger, on the other hand, is always listening, and as soon as the defined event happens, it will initiate the Logic App. The main difference is that a polling trigger runs according to a defined schedule, where a push trigger is always listening. So whenever a qualified or defined event happens, it will run right away on the push trigger, and then it will run during the next polling cycle on the polling trigger. Connections allow you to integrate your Logic App with other resources. This can be an Azure resource such as Blob Storage, or it can be a resource outside of Azure. There are also third-party resources such as Salesforce, Office 365, RSS feeds, Google's G Suite, as well as many others. As mentioned, you also have the option to create a custom connector if needed. As part of the connection, you define what you're looking for. For example, if you want it to run when a blob is added or modified within a storage account. Once you have the connection defined, we now define the action. The action can include any number of steps that you defined. This can be as simple as sending a notification when the storage blob is updated to deploying a new environment when a request is submitted. The options are essentially limitless depending on what your needs are. Logic App Designer is a graphical way to design your Logic Apps. It is the default option when you create a Logic App, and there are a number of existing templates that Microsoft has created that will help you get started. You also have the option to start with a blank Logic App. Within the Logic App Designer, you have a number of options for how your Logic App will be triggered. It can be on a schedule using a polling trigger, or you can have it on a connector so it'll be triggered once the event happens using a push trigger. Once you have your trigger defined, you can now create a workflow. The example on the right is checking Twitter and then filtering for tweets with the word Azure in them. Based upon that logic, it will execute either the true or false workflow. An advantage of Designer is that you can easily view the associated JSON code in the same window. As you get more complex Logic Apps, it may be helpful to create part of it within Designer and then do some fine-tuning within the code. With Logic Apps, there are two deployment models. The first is consumption-based or serverless. This tier only charges you for the resources that you use. But instead of runtime or memory consumed, you are charged based on the number of actions, triggers, and connectors that you use. So if you have a Logic App that has many steps and a number of connectors, it will typically be more expensive than a Logic App with fewer steps. It is also worth noting that the type of connector you use will have an effect on the cost. There are built-in connectors which are typically used with Azure services. The standard tier offers many more options for third parties and does have a higher cost. The enterprise tier is used when integrating with IBM and SAP. The other option is the ISE or Integrated Service Environment. This is a fixed price. You are limited by the capacity of the SKU. With an ISE, you do not pay for the connectors regardless of the type. There are two options, the first being developer. This is a lower cost tier that offers no SLA and does not allow scaling. Additionally, it offers no redundancy, so if any maintenance is done in the backend, there could be temporary outages. The premium tier does give you the ability to scale up to meet your Logic App's needs. Additionally, it offers an SLA and is geared more towards production workloads. Another important difference that may help determine the appropriate SKU is if you need to integrate your Logic App directly into your VNets. The consumption-based tier does not offer this. The only way they have this feature is if you use an ISE. Now that we understand the components of Logic Apps, let's go into the portal and create one. So here we're back at the Azure portal. What we're going to be doing today is looking at Logic Apps. So let's go ahead and take a look at Logic Apps. And you can see right now we don't have one deployed, so let's fix that. Go up here and click on Add. And we're going to select the resource group of Skylines once again. And now we need to define a name for Logic App. So let's just call it Skylines LA for Logic App. We're going to leave this in basically a region deployment instead of selecting an ISE, which basically means we're going to be doing consumption based. And then we're going to go ahead and leave the defaults here. We're not going to define a tag, but let's go ahead and create this. So once this starts deployment, it should finish up here pretty quickly. Our goal is, once this is deployed, we're actually going to go through and create a Logic App so I can show you how it works. So now that it's completed, let's go to the resource. And you can see by default it opens right up to Logic App Designer, which, as we talked about, is basically a graphical way to deploy a Logic App. Let's go and take a look at the Logic App itself first before we dive too far into that. So you can see for the deployment tools, we've got the code view as well as the designer that we just saw a little bit ago. We've got versions as well as connections, and then we've got some of the settings as far as authorization and access keys, as well as if we need to set up any sort of managed identities. Let's go take a look now at the code view. So what I'm going to do now is I'm basically going to remove all this. I've got a template that I've already created here in Visual Studio Code. So I'm going to select this, and I'm going to paste this in here and save it. So now that we've got this saved, let's go actually to the designer view so we can take a look at what's going on here from a graphical perspective. So what it's doing is basically it's looking to see when a new tweet's posted. So we open this up, searching my account to see if a new tweet's been posted, and it's going to check that every minute. Then if we drop down to conditions, it's going to go through and say, okay, does that tweet contain the word Azure? Well, if so, let's go ahead and send an email. Let's call a sample function, and if we remember right, this was a function that we created earlier, and then we're going to post another tweet. However, if it does not contain the word Azure, then we're just going to send an email. Well, let's go see it work in action. So if we go to my inbox here, you can see we don't have any unread messages, which as a side note is a first. And then if we go to Twitter, let's go ahead and say sample tweet Azure. And let's go ahead and hit tweet. So we've got our sample tweet here. And just to speed this up, I'm going to go ahead and hit run. So now it's basically going to go through and do its process. And if we notice, hey look, I got an email up here. Sweet. So it looks like, hey, I've tweeted. Sample tweet Azure. All right, that's cool. Now let's go back to Twitter, hit home, and look at that, I sent another tweet, and if I open it up, hey, look at that, it's still true. So again, to take a step back and look at what's happening, a tweet's been posted, it looked at that tweet to see if it had the condition there, it sent an email, it called a function which then in turn created this image, and then it posted a tweet again with that image, so it was able to pass that along. So now if we go back up here and just say, sample tweet without any fun words, and we go ahead and tweet that, and let's go back here and let's run it again just to speed things up. And look, I got another email here, and sad face. It's cool, but whatever. So go ahead and look over here. No follow-up tweets, just that one that I sent. And if we did notice here, you can see here though it actually came up twice, and that's because just that timer that was every minute happened to pick that up at the same timer before I hit the run command. So just because of timing and because I manually ran it, that's why we got this twice. If I would have let things be, we'd only had it once. But this is just an example of how you can use Logic Apps to connect multiple systems together. If we look here, we can actually see the logs of this command. Because now we can see the outputs, we can see what happened, and basically, did this condition, the output was false. So in that case, it didn't do anything here, but it did go through and run down here, and you can see we've got the X versus the green check marks to basically say this didn't run. So again, you get a nice kind of output here as far as what's going on. If we go back to designer, which again is basically the same thing we're in, If we wanted to change this to where, it searched for every 10 minutes, we could go through and update that. Or for the condition, if we wanted to look for a different word. As you're working through this, it gives you a lot of flexibility to connect many different systems. Because again, we're looking at a tweet, we're sending an email, we're calling a function, and then we're following back up with a tweet. So if we look back at Logic App Designer and we want to take a look at some of the connectors, we can hit this plus arrow. We're going to go ahead and add an action. And then we can see here we can go through and select all. And now we're going to take a look at some of the various connectors. So we have some of these here, but if we hit the drop down, now you can see we've got a pretty massive list. And we've got our built-in ones. If we start there, these are going to be typically mostly Azure resources. If we go up to your standard, now we start getting into some of the third party. And given what we see here is a lot of Azure related or Microsoft related, if we scroll down, you can see now we're starting to see some of the other ones. So Ally, Amazon, Bitly, Bitbucket. And as you can see the list, we're still in the B's, so the list is pretty massive. And if we go to Enterprise, now we see the IBM and the SAP type applications. And if you remember right, those have a higher cost tier. But again, the overview of this is to kind of help show you some of the power of Logic Apps. And not only can we do everything via code-based, as we did when we started this, since we basically copied in an existing code, but you can also use the designer view. Again, I think the designer view is great if you're looking to get started or fine-tune an existing Logic app. But once you have that set up, copying that code and then being able to paste it and move it around is incredibly helpful. And it gives you the ability to templatize your Logic apps in a very effective and efficient way.